Hello everyone, I am Manas Kumar Patti, currently pursuing my MSc Chemistry at NEET Raulkala. I am here to simplify one of the most fascinating concepts in organic chemistry, that is aromaticity. We will dive into what makes certain cyclic compounds extraordinarily stable and makes it unique. Before starting the lecture, and to clarify, what should be our key objectives of this lecture? That means what we are going to learn in this lecture. In the first part, we are going to learn that the key facets of aromaticity. That means what do you mean by aromaticity? We are going to learn the definition of aromaticity and the Huckel's rule. And in the second part, we are going to learn that how to know that a compound is aromatic, anti-aromatic or non-aromatic. That means what should be the criteria that aromatic compounds should follow and an anti-aromatic compound should follow and a non-aromatic compound should follow. And in the last part, we are going to solve some problems related to aromaticity to solidify our understanding whatever I study in this lecture. And also we will solve some previous year questions related to IIT JEE Mains and also JEE Advanced, so that we will solve each and every problems related to aromaticity. And before starting to the lecture, I want to clarify that after end of this lecture, I am taking the responsibility that you are able to solve each and every problems related to aromaticity. Okay, let's come to the discussion. Before entering into the definition of aromaticity, I am to start the lecture with a question that why benzene is, have you ever wondered that why benzene is so stable despite having unsaturation? The answer should be benzene is aromatic compounds. So now question is how we know a compound is aromatic or not. Now let's come to the definition of aromaticity. Aromaticity is a property of certain cyclic compounds that exhibit exceptional stability due to delocalized pi electrons. The aromaticity is I want to repeat it again. Aromaticity is a property of certain cyclic compounds which exhibits exceptional stability due to delocalized pi electrons. Now question arises that here is the definition of aromaticity. Now how we know a compound is aromatic or not? There are certain rules we have to follow to know a compound is aromatic or not. The important point is that we have to follow the rule sequentially. First of all, that means we have to follow the rule serially. Okay, let's enter into the what should be the rule or what should be the key features to check the aromaticity in any compound. What should be the conditions to check the aromaticity in any compound? The first condition should be the compound must be cyclic. Now question is why the compound must be cyclic? The compound must be cyclic. There is a reason to allow the continuous overlapping between p orbitals. Next, the compound must be planar. Now again question arises how we know that a compound is planar. The compound is said to be planar if all the atoms in the ring is sp2 hybridized. Let's take one example to define a compound is planar or not. That means in the ring, if all the atoms is sp2 hybridized, then the compound is said to be planar. Now there are certain that means how we know that compound is sp2 hybridized. There are two. That means if 3 sigma plus 0 lone pair, that is said to be sp2. If there is 2 sigma and 1 lone pair, that is 3, that is total should be sp2 hybridized. And we will also learn these concepts whenever we are taking some examples. During that we will clarify all these concepts. And in the third point should be there should be cyclic conjugation should be there. That means if in a compound there should be cyclic conjugation, then the compound is said to be aromatic. Now, if all the three conditions is satisfied by a compound, then we have to move to the fourth condition. That is, if a compound contains 4n plus 2 pi electrons. That means if n is equal to 0, then 2 pi electrons. If n is equal to 1, then 6 pi electrons. 4 into 1 plus 2, that is 6 pi electrons. If n is equal to 2, then 10 pi electrons. If a compound follows first the three conditions and also that compound contains 4n plus 2 pi electrons, then the compound is said to be aromatic. That means this rule is said to be Ockel rule. It is a very important rule in organic chemistry. So, if first the three condition is satisfied by any compound and also the fourth condition is satisfied by that compound, then that compound is said to be aromatic. If that compound satisfies the first three conditions and also contains 4n pi electrons. That means if n is equal to 1, then 4 pi electrons. If n is equal to 2, then 8 pi electrons. If n is equal to 3, then 12 pi electrons. Then the compound is said to be aromatic, and here the compound is said to be anti-aromatic. Now we know the rules of how to check the aromaticity in any compound. That means I want to clarify again. That means if the first three conditions is satisfied by any compound, that means the compound must be cyclic, planar, and the third condition, that should be cyclic conjugation is there. And if it is satisfied by any compound, then you have to check if there is 4n plus 2 pi electrons or 4n pi electrons. If there is 4n plus 2 pi electrons, then the compound is said to be aromatic. If it contains 4n pi electrons, then the compound is said to be anti-aromatic. Now question again arises. We know that what a compound should follow. For a compound to be aromatic, what is the condition? And for a compound to be anti-aromatic, what are the conditions? Now question again arises that what is the conditions for non-aromatic compounds? For a compound is said to be non-aromatic compounds, what are the three rules we have studied or three conditions we have studied previously? If any one of them is failed, then the compound is said to be non-aromatic. Now we will discuss some problems related to aromaticity, and we will clarify all of these conditions whatever we have studied, and we will know when a compound is said to be aromatic, when a compound is said to be anti-aromatic, and when a compound is said to be non-aromatic. We have already discussed the conditions of aromaticity. Now we will solve some problems related to aromaticity. That means comment on the aromaticity. There are three compounds. We will find out that which compound is aromatic, or which compound is non-aromatic, or which compound is anti-aromatic. First of all, let's come to the benzene. You have already known that the compound is benzene is aromatic. Now we will define that how this compound is aromatic. The first condition should be, I have already told you that we have to follow the condition sequentially. That means serially. The first condition should be cyclic. The compound is benzene is cyclic. That means the first condition is followed. And the second condition is the compound should be planar. That means there should be sp2 hybrids. All the atoms in the ring should be sp2 hybrids. That means here there is one hydrogen atom. That means 1 sigma. There is 2 sigma. There is 3 sigma. That means total there are 3 sigma. So that is sp2 hybrids. So all the carbon atoms here, all the 6 carbon atoms are sp2 hybrids. That means the compound is planar. Let's come to the third point. That is, there should be cyclic conjugation, complete cyclic conjugation. Here there is double bond, here there is single bond, here there is double bond. That means here there is single bond, again double bond, again single bond, again double bond. That means there is continuous cyclic conjugation is there. That means the third condition is satisfied. Now let's come to the fourth condition. Fourth condition. That means there should be 4n plus 2 pi electrons or 4n pi electrons. 4n plus 2, if it contains 4n plus 2 pi electrons, then it is aromatic. If it contains 4n pi electrons, then it should be anti-aromatic. Let's check the how many pi electrons are there. There is 2 pi electrons, there is 2 pi electrons, there is 2 pi electrons. So there is 6 pi electrons. 6 pi electron means it's follow 4n plus 2 pi electrons rule. So the compound follows all the 4 rules of an aromatic compound. So the compound is aromatic. Let's come to the second point. So here it is a little bit different to the first compound, that is benzene. So here first we have to check first condition. The first condition should be cyclic, the compound is cyclic. The second condition, the compound should be planar. Here the compound is planar. How to check? Here there is one hydrogen bond. So 1 sigma, 2 sigma, 3 sigma. That means total let's check the second compound. Here is little bit different from the first compound. Here first condition should be the compound should be cyclic. The compound should be cyclic. First condition is followed. The second condition, the compound must be planar. That means you have to check the hybridization of each compounds of the ring. If all the compounds, all the atoms of the ring in the ring is sp2 hybridized, then the compound is said to be planar. Now check the hybridization. Here there is one hydrogen atom. So there is 1 sigma, there is 2 sigma, and there is 3 sigma. That means there are 3 sigma are there. So it is sp2 hybrid. And also this carbon atom is also sp2 hybrid. Here there is also one hydrogen atom. Here is also one hydrogen atom. So all the atoms, all the carbon atoms are sp2 hybridized. So this compound also followed the second rule, that is this compound is planar. And the third rule, the compound there should be cyclic conjugation is there. I have already told you in the whenever I studied the conjugation part. That means here there is positive charge A, suppose B double bond C. Here is one carbon atom, this one. Here is another carbon atom B. Here is another carbon atom, that means C. That means positive single bond and double bond. So here is also cyclic conjugation is also followed. And the fourth one, that means we have to check how many pi electrons are there. Here there is 2 pi electrons. There is 1 pi bonds only, so there is 2 pi electrons. So this compound 2 pi electrons means the compound follows all the conditions of a aromatic compounds. So this compound is also aromatic. Already discussed the first example and the second example, and in the third example we are going to learn one important concepts regarding the hybridization. In the third concept, in the third question, the first one should be the compound should be cyclic. The compound is cyclic. The first condition is followed. The second condition, the compound should be planar. We have to check the hybridization of each atom of the compound. The first step, if you are going to check the hybridization of this carbon atom. Here is 1 sigma. Here is another sigma. Here is another sigma. That means there are 3 sigma. It is sp2 hybridized. And again here there is 3 sigma. It is also sp2 hybridized. Here is 1 sigma, 2 sigma, 3 sigma, and also 1 lone pair. That means here there is 3 sigma plus 1 lone pair. It is 4. That means sp3 hybridized. If we are doing like this, then the concept will be totally wrong, because here the negative charge is participating in the resonance. Whenever the negative charge is participating in the resonance, we are not going to calculate it or consider it in the hybridization. For example, if there is A, B, double bond C, here is negative charge. If the negative charge whenever is going to participate in the resonance in this with this double bond, then this negative charge will not going to be participate, or we are not going to consider this negative charge while calculating the hybridization. So this compound, so the hybridization of this compound is not going to be sp2 sp3. How? Because we have to eliminate this one lone pair here. So there should be 3 sigma bonds. So the hybridization should be becomes sp2. So the second condition is followed. And in the third condition, the compound there should be cyclic resonance. There is complete cyclic resonance. Negative charge is there, single bond is there, double bond is there, and again single bond is there, again negative charge is there. So there is cyclic complete cyclic resonance is there. That means third condition is followed. And in the fourth condition, we have to check how many pi electrons are there. Here there is two the negative charge. The negative charge is participating in the cyclic resonance. So we have to consider it as pi electrons. So there are 2 pi electrons. For 2 pi electrons, that is 4 pi electrons. That means the compound follows or satisfies the condition of a anti-aromatic compound. So I have already told you that if the first three condition is followed, and if the compound contains 4 and pi electrons, then the compound is said to be anti-aromatic. So this compound is anti-aromatic. Let's take one questions of IIT JEE Advanced. That means one previous question of IIT JEE Advanced. The question is that among the following compounds, the number of aromatic compounds is. That means we have to calculate how many aromatic compounds are there. I have already taught this type of compounds in my lecture. That means the compound should be it should be anti-aromatic. I have already discussed it. There is 4 pi electrons, so the compound is anti-aromatic. And this example I have also already taught. That means the compound is aromatic because here is 2 pi electrons. Here we are going to learn this example. That means here there is 4 sigma. That means it is sp3 hydride. So this compound is non-aromatic. And why this compound is non-aromatic? Because I have already told you that if between the first 3 conditions, if one condition is failed, then the compound is said to be non-aromatic. Here the compound is not planar because there is sp3 hybridized carbon atom. So this is non-aromatic, and here the compound here is also it is sp2 hybridized, and all the carbon atoms are sp2 hybridized, and also it is cyclic, it is planar, and also the compound contains 6 pi electrons. So it is aromatic. Here again there is 4 pi electrons, it is cyclic, planar, and also it contains 4 pi electrons. 3 sigma, that means sp2 hybridized, so it is also contains 4 pi electrons. So it is anti-aromatic because it contains 4 pi electrons. I have already discussed that the conditions of how to check the aromaticity. So that's why I am going so fast. So here there is again all the carbon atoms are cyclic, and it is a planar molecule, and also it contains I have already told you that if the negative charge is participating in the cyclic resonance, then the negative charge is going to be considered as pi electrons. So here there are 6 pi electrons, so it is also calculated as aromatic compounds. And here again there are 1, 2, 3, 4, 5, that means 10 pi electrons. So it is also aromatic, and also the compound is cyclic and also planar, and also cyclic conjugation is there. And also here there is also compound is planar, and also the compound is cyclic because there are all the carbon atoms are here sp2 hybridized. The compound is planar, and also it contains 1, 2, 3, 4, 5, 6, 7. That means 14 pi electrons. It also contains the 4 and plus 2 pi electrons, so the compound is aromatic. Let's come to the question. That means among the following, the number of aromatic compound is. Here there is one aromatic compound, and here again it is also aromatic compounds, so 2, and here it is also again aromatic compounds 3, 4, 5. So the answer of this question should be 5. So we have already solved one previous question of JEE Advanced. So similarly this type of questions are coming in JEE Advanced as well as in JEE Mains. So whatever I have taught, you can easily solve all the problems related to aromaticity. To summarize, if a compound contains or satisfied the first 3 conditions, that means the compound should be cyclic. The second condition is the compound should be planar. Third condition is the compound there should be cyclic resonance is there. If these 3 conditions is satisfied by the compound, and the compound contains 4 and plus 2 pi electrons, then the compound is said to be aromatic. If the first 3 conditions satisfied and the compound contains 4 and pi electrons, then the compound is said to be anti-aromatic. And if any one condition from the first 3 conditions is failed, then the compound is said to be non-aromatic. I have already solved few examples related to this concept, that means aromaticity, and also I have solved one JEE Advanced questions, previous questions of JEE Advanced, and I encourage you to solve more and more problems related to this concept. And if you have any doubt, then you can feel free to ask. Thank you for watching. Keep studying, keep growing. Thank you.